So we're going to go into a little bit more detail about motion in this video and the idea of some more scalar and vector quantities. So let's say that you were going to travel from Asheville to Seattle. You would start here and you could drive down through Texas and up through California and get there that way. Or maybe you drive up this way and you go through Wisconsin, visit my family, and head this way. Or even you could drive up into Maine and go all around and like go through Canada and come back down around and end up over here in Seattle, right? So there's lots of different paths that you can take to get to where you're going. And in every single one of those instances, you start at the same location, you end at the same location, but you have covered a different amount of ground, right? You've traveled different numbers of miles. And those different numbers of miles, that is the distance. So distance is the ground that the car has covered, right? It would be what your odometer read, how many miles you've gone. And, you know, if I was going to say a value, I would say like, I don't know, 3,400 miles, right? So notice that expression has a number and it has a unit with it, but it doesn't have a direction. So distance is actually a scalar. Now, for every single one of these instances, you started in Asheville and you ended up in Seattle, right? So if I were to draw just a straight line that connected the two, it would be from here to here, and I draw an arrow because this is actually a vector quantity, and this we call displacement. And displacement is defined by the change in position, right? So if I was going to express this, I've actually looked up exactly what the displacement is. It's 2,892 miles, 25 degrees northwest from Asheville to Seattle. And so we see here we've got both a number, but we also have a direction as well. And so this is a vector quantity, right? So this is a vector, right? Now, for every single one of these, the displacement is the same, but the distance that it's covered is different. Now, if we were going to express this mathematically, change in math is written with the Greek letter symbol delta, so with a triangle. And I like to use D for displacement. There's lots of variables that people use, but so your change in your position, or D, would be equal to your final position minus your initial position. Okay, so this is how we would calculate it. Now, like I said, there's other variables. Sometimes people like to use X or even Y, just depending on your coordinate system. Sometimes you'll see in textbooks that there R will be used for a position or even S used for a position. So just keep in mind that a variable is just a letter that represents, you know, a word. And so you can pick whatever makes sense to you, but most often I just use D because it's displacement and that makes sense to me. So as you travel around from one location to another, inevitably time passes. So that's where we get to the idea of defining both speed and velocity. So speed is the idea that as you go a certain distance, time passes. So distance divided by time is how we calculate the speed. It's the miles you travel in an hour. Okay, and speed is, because distance is a scalar, speed is also a scalar. So the unit for that would be, you know, meters, which is typically what we use for distance, or displacement. We said back here that the variables were these letters, but the base unit in physics for distance or displacement or change of position is meters, which is written with a little m, right? And the base unit for time is usually seconds. So most often you'll see speed represented as meters per second. But you could have kilometers per hour, or meters per hour, or anything like that, some distance over time. So then if we look at, this is distance over time, so we know there's a difference from distance to displacement. So we also have the idea of velocity. which is taking the displacement over the time. Now, because displacement is a vector, that makes velocity also a vector. So when we calculate this, we need to both include the unit of meters per second, but we also include direction. So maybe, like 300 meters per second, 25 degrees northwest. All right? Now, as you travel, let's look at this path again. As we travel around, right, if you're on a highway, sometimes you're stopped, sometimes you're going fast. So, sometimes you're going 75, maybe sometimes you're going 85, right? So, at every individual point, we have something that's called like the instantaneous speed or instantaneous velocity. This is what it would say on your speedometer. Exactly, like how much are you going, how fast are you going right now at this position. But we also have the idea of the average speed or the average velocity. Right? And because you are changing your speed as you travel along and the time is changing, you can't just add up. Usually when you do an average, you add up all the little parts and you divide by how many you have. Well, that doesn't really make sense in this case because, if you're going 100 miles per hour for a majority of the trip and then you're stopped for like 10 seconds, your average velocity is not going to be like half of 0 plus 100, right? It's not going to be 50. It's going to be faster than that. So when you calculate average speed or average velocity, we can kind of use those interchangeably. What you do is you put the total distance on top, and you would put the total time on the bottom. So, even if for a part of the trip you're not even moving, for like 2 hours you're not moving, that's included in the total time. Right? So average speed or average velocity is going to be the total distance or displacement over the total time. Right? So I think that gives you enough of a little bit of a background to get in working with some problems and solving some basic motion problems.